Happy Thursday, even though it's kind of the end of the week, so it's like a Friday. Today we're just going to be hitting a lot of vocab words as we start getting into graphing polynomials. We've been talking about how to do some work with polynomials like dividing and things like that this week, and now we're going to look at their graphs. So first off, what is a polynomial? It's a math sentence with many terms. And you're going to be asked today to do this, to classify by the number of terms. Something has one term, it's a monomial. And again, if you don't know what a term is everything in a math sentence that's separated by plus signs, minus signs, equal signs, or parentheses. Kind of like spaces in a math sentence. Or in a regular English sentence, I guess. So, again, if it's got one term, monomial, two terms, binomial, three terms, trinomial, and if it's got four or more, we just give it the generic term polynomial. All right, next we're going to talk about the degree of a polynomial. Now, a degree is the highest sum of the powers of the variables in a single term. So, again, most of the time you're talking about one variable, and you're just looking for the highest power. But if you have a math sentence with two variables, like say, for example, x to the third, y to the second, that would have a degree of 2. You're adding up the degree or the sum of the powers of the variables in a single term. So again, that's what it means by the sum. Now, most of the time, we're not going to have that. We're going to be looking at most of the time just plain old x or plain old y. All right, so here are some examples of classifying by degree. Something has a degree 0, that's a constant. If you're asking, well, where's the degree 0? Well, it comes from this. The x has a degree of 0. If you remember from algebra, anything with a degree of 0 is essentially 1, so that equals 6 times 1, which is just 6. Which is why we don't write the x at all when it has an exponent of 0. But that's its official degree, 0. Now, if something has a degree of 1, that means it's called linear. You did this when you did slope-intercept form. Now, we don't normally write the exponent 1 there over the x, but it's there. So again, that's a degree 1. We call it linear. It should look like slope-intercept form. Then degree 2. Those are called quadratics. We learned how to graph those, called parabolas. And that would again be when we have a highest degree exponent of 2. Then a degree 3 is called cubic. Should have had a little bit of experience with these ones in Algebra 2, but probably not very much. And again, that means that the highest degree, you can see it there in the front, is the degree 3. Right? Anything more than that does have names. There's quartic and quintic and things like that, but they're not anything we're going to use. We're going to stop here with our work. Right, a few more words to talk about next. Got to talk about what's called standard form. All right, standard form is when a polynomial is written in order with the largest degree first down to the smallest degree. And here's some ugly notation that you'll see here. And again, I'll explain what this really actually looks like here. First off, we got the dots out front, which means this goes forever in the up direction. We don't have to stop. But again, we're not going to look at anything ridiculous. All right, what we want is then everything in order from highest degree. You can see that we're going from 5 to 4 to 3 to 2 to 1, which we don't write, to x, which we don't write, or x of 0, which we don't write. So again, some of those things aren't in there, but we keep them in that order. It's all about the order of the exponents. Now, the little a's out front, that just means that they can be coefficients, and they all have different numbers just to match their exponent. No real reason or no real meaning on that other than the a that's right here can be a different number than the a that's with this one, which can be different than the a that's with this one, which could be different than the a that's with this one, and so on. All right, next, what's called the leading coefficient. That is the coefficient from the term with the highest degree. Essentially, the very first number in the math sentence. Very first thing. All right, then we're going to talk about what's called the leading coefficient test, and this is really useful for graphing. It's going to show us the end behavior of the graph. So we're going to refer to anything going to the right as x approaches infinity. And the reason we do that is because of the x-axis, as we go to the right, that number would be infinity. And then to the left, that would be pointing us towards negative infinity. So that's what that notation there means. So we'll see a little bit of this in the next problem. We'll do an example in a moment. All right, so that leading coefficient test, what does it tell us? Again, it tells us what the graph will look like at the end points, on the far ends. So we'll do some examples. So first off, if you have an odd degree, that means exponent 1 or exponent 3 or exponent 5. So an example could be something like y equals 2x minus 3. That has an odd degree. Exponent on the x is a 1. All right, if you have that and your leading term is positive, all right, that means this number here is positive. Then what that means is on the left-hand side of the graph, you should see the arrow pointing down. On the right-hand side, you should see it pointing up. And we should know that that has an intercept at -3 and a rise over run of 2 over 1. That would be what that graph looks like. And you can see on the left, it's pointing down. On the right, it's pointing up. What happens if that's reversed? What happens if the leading coefficient's negative, like -2x minus 3? All right, well, it tells us that the pattern will be that on the left it's going up, on the right it's going down. So again, we know what this would look like because we know slope-intercept form. We'd have a slope of down 2 and over 1, and something that would look like this, where again on the left it's going up and on the right it's going down. It's giving us some direction. Right? That doesn't only work for straight lines, it works for curved lines too. So let's talk about even degrees. Even degrees would be things like quadratics, like for example y equals x squared. And that's an even degree quadratic. It should make a parabola. Since its leading coefficient, which would be 1, since that would be positive, then this is telling us that both ends should be pointing up. And we know that the parabola should be pointing up on the left and up on the right. Both ends point up. If that leading coefficient's negative, but the degree is odd, and we have, for example, negative x squared, again, the leading coefficient would be the -1. Our degree is degree is even, that's exponent 2, and we know that this graph would look like this, where on the left it points down, and on the right it also points down. So again, we get some ideas of what the graph looks like based on some of these numbers. Now, we're not really doing any math or calculations. Everything today is just vocab based. So let's try an example. All right, first off, we want to put this in standard form. Right now, it is not. So let's do that. Standard form says start with the thing with the largest degree first. So the -5x to the third should come first. Then the next highest degree, which is exponent 2. The next highest degree, which is exponent 1. And then finally exponent 0, or our constant term. All right, now what is the degree? Well, the degree is the highest of all those exponents, so it's right there. Our degree is 3. Now we want to classify by degree. So what do we call something that's degree 3? All right, well, something that's a degree 3, if you went back to your notes, back in the beginning, we talked about classifying by degree, and that'd be right here. Degree 3, we see at the bottom, that'd be cubic. So that answer would be cubic. Then we want to classify by the number of terms. So how many parts does this math sentence have? So you can go back to the top where I underlined them, and there was 1, 2, 3, 4 terms. Something that has 4 terms is called a polynomial. If it has 1 term, it's called monomial. Again, we can go back to our notes, and we're looking here. Again, everything's just vocab based today. All right, next, what's our leading coefficient? Well, that's the very first number at the start of the problem. In this case, -3. Just the coefficient, not the x. Oops, sorry, not -3, I'm silly. -5, I'm looking at the top line here. It has to come from the leading term. And the top line's not in standard form. I almost made a mistake there. So again, it's easy to make a mistake. All right, last but not least, ending behavior. So let's see what we got. We got degree of 3, so we've got this odd degree. So we have 2 choices. It could be down on the left and up on the right, or we could be up on the left, down on the right. This would be kind of like positive and negative slope. All right, so I need to check that leading coefficient. Since my leading coefficient is -5, that's kind of like a negative slope. So think about how negative slope would look. Negative slope would be one going down from left to right, which means on the left-hand side, as we approach negative infinity, the graph is going up. On the right-hand side, as we approach positive infinity, the graph is aimed down. Now, obviously, this is going to be the place where you have the most confusion. We'll also be working on this particular place for a couple of days. This is not going to go away after 1 minute. So again, that end behavior is probably going to be where you need some help, so let me know if you do. I know this was a long video today, but again, the notes are mostly just vocab related. All right, good luck.